I'm going to talk about routing protocol in mobile ad hoc networks. This mobile ad hoc networks is coming under the wireless networks. The wireless networks is been broadly categorized into two divisions. One is with infrastructure, the other one is without infrastructure. With infrastructure means existing networks, the towers, everything is going to be used, and example for this networks is cellular communication. But we are going to see about without infrastructure, which is really needed nowadays. In the without infrastructure, the wireless networks consists of mobile ad hoc networks, and then wireless sensor networks. First, we are going to see about the ad hoc networks. The ad hoc networks have configured without any kind of infrastructure. It requires no hubs, access points, base stations. These are instantly deployable. It can be wired or wireless. Based on the needs, we'll be having some of the wireless and some of the components will be wired. Initially, the ad hoc networks are being used for military applications and emergency application. Okay, let us see about what is MANET, Mobile Ad Hoc Network. Ad hoc, as such, we have seen it without any infrastructure. We are going to configure the network, and if these electronic equipments are having the mobility, then it will be coming under mobile ad hoc network. And already these networks are deployed without any infrastructure. So routing is the main issue, and within that, if you are going to have the mobility, that is also going to be tackled. So outline of this topic is characteristics of MANET, and then we are going to see about the routing, table driven and source initiated on demand hybrid. Mobile ad hoc networks, the features are autonomous and infrastructure less, multi-hop routing, dynamically changing network topologies, variation in link and node capabilities, energy constrained operation, and security is also one of the major issue in mobile ad hoc networks. Here we can see the example of the network. But before going to proceed about the routing protocol, let us list out the issues of ad hoc wireless internet. Pricing and billing. Nowadays, the billing strategies for the ad hoc wireless internet, that is very important. With that, we have to include the security. So it is essential to include the security mechanism in the ad hoc wireless internet. Along with that, quality of support. That is, we are going to have the voice over IP, so that is also to be taken care. And along with that, service, address and location discovery. Because when we want to route a packet, where is the real node? That location discovery is a major issue, and that can be identified, and to them it should be serviced. And categorization of mobile ad hoc routing protocols is being given in the slide. It is being broadly classified into three. One is proactive protocol, the other one is reactive. With these two good features are combined, and we will be having hybrid protocols. First, let us see about the proactive protocol. It is predetermined. Once the network is deployed, we will be having that is table. That table will be having the routing information, where is the node and how that node can be reached. Everything would have been given in the tabulation, and that is called as the proactive. Before the routing is taking place, we will be having the routing protocol, and that may be called as the proactive protocol. But in the reactive protocol, at the time of demand, we are going to establish the path. Only at that time the path would have been established, and through that path these packets are going to be routed. But if you are coming to the hybrid protocols, proactive means you will be having the table, routing table established, and then we are going to make the routing. So fastest in its routing. But whereas in the reactive, since there is no maintenance of the routing table, routing itself is going to be a big problem. But in the hybrid protocol, only for a certain zone, we can have the proactive, and beyond that area we will be using the establishment of path, and based on that the packet would have been routed. So these two good features are combined, so we will be having the hybrid protocols. Let us see about the proactive protocol subdivision: DSDV, destination sequence distance vector, then wireless routing protocol, then FSR. In the reactive protocol, ad hoc on-demand distance vector, then dynamic source routing, next one is ABR. And in the hybrid protocol, we are going to have the zone routing protocol. Within the zone, we will be having the proactive. Beyond the zone, we will be having the reactive protocol. Let us see the picture illustrating the animation, which will be illustrating MANET routing protocol. The node A, that is supposed to be source node, and B, that is supposed to be the destination node. The other nodes are given it as neighbors. Whenever we want to establish the communication between A to B, like this, the path would have been established. But whenever the neighbor node is been moved, since we have taken the mobility, how that path would have been maintained. Now if you are going to see, the path would have been taken it in a different manner. It is not the same path. So again, in this place, if any other neighbors have been moved, now you can see the other node is coming inside. This is a new node coming into the network. Again, how the path would have been established means only in this manner. So we cannot rely on the established path all the time. And the factors affecting MANET routing are number of nodes, mobility. Other factors includes traffic, quality of wireless channel, and the scalability. If the number of nodes are going to be increased, that itself is giving some problem in the routing. Mobility. If the nodes are going to have a very good mobility, then also the routing is a big problem. And if the mobility is going to be very rare or very in a small manner, then the routing is not going to be a big problem. So these are the issues we will be making it, and proactive protocol is going to be suitable for this contest whenever we are going to have the less mobility. But whenever we will be having the high mobility, we have to go for reactive routing protocol. Each routing protocol is designed to achieve an optimal performance based on a particular network context. No routing protocol have the optimum performance in all network contests. MANET is designed to employ a specific protocol and cannot benefit from the advantages of other protocols. We will be seeing about some of the routing protocol as we have listed in the categorization. In this, first we are going to see about dynamic destination sequence distance vector. Each node knows the state and topology of the entire network. Routes are chosen by a metric, least delay, best signal strength. Like that, any one of the parameter or any one of the metric can be chosen. Based on that, the routes are being chosen. Periodically, and when triggered, transmits the entire routing table to neighbors. Full dumps or incremental dumps. Avoids loops by using sequence number. That's why the name is being given destination sequence distance vector. In the DSDV routing protocol, we are having these four entities: destination, next hop, metric, sequence number. Route advertisement, that may be periodic or even triggered. Periodic means full dump about the entire information. Even triggered, whenever there is something happened, only with the additional, the new changes, that alone will be included. So that is called as incremental update. Updating the routing table, the route entry with a higher sequence number is chosen. If the sequence numbers of two route entries are the same, the one with the smaller metric is chosen. DSDV recovery. When a link loss is detected at node N, the metric of the route to the destination through the last link is advertised as infinite, and an incremental update is flooded to the neighbors. This will be giving about loop avoidance problem, or you can call it as count to infinity. And this is a method we can see about the DSDV evaluation. Constant routing overhead versus mobility. So this one also has, that is overhead increases as the number of node increases. DSDV can no longer find a route reliably when there is a high mobility. Now we will be moving on to the next routing protocol, DSR, but this DSR is coming under the reactive routing protocol. Routes are kept in each packet, routes to that point in request packet, full routes in data packet. Routes are cached at each node to limit flooding of request packets. Any route that is seen through a node is cached. Source sends out request packet. Any node which is the destination of a node which has a route to the destination replies with a route reply. DSR recovery. A route error is sent to the source. All nodes along the path remove that route. Source uses a cached alternate route to destination or sends out request packets for a new route. This consists of two phases, that is route discovery. Start with checking route cache, then start RRP with a unique identifier. So each node will be making the route discovery to the destination. This is consist of two phases. One is supposed to be route discovery, and once it has reached the destination will be giving the route reply. And how the evaluation always delivers at least 95% of all packets sent in all cases. Routing packets are large because of the source routing, and the way how the dynamic source routing is working is, when a source S wants to send a packet to node destination D but does not know a route to the destination, node S, that is the source node, initiates a route discovery. Source node S floods route request. Each node appends own identifier when forwarding route request. This is the manner we will be making the source from the source to the destination. So this is the one after it has been given the broadcast transmission. Then from C and E we will be making it to the next nearby one, and from G and F to the nearby J and K. Finally it will be reaching to D, and from D we will be making the reply. So this one will be coming from D, that will be coming to J, and then F, and then E, then that will be given to the source. So this arrow mark represents route reply control messages. So route reply is making the DSR how to make the data packet to be communicated from the source node to the destination node.